Hello children, you're welcome to this video session. আজকে আমরা Trigonometric Identities chapter নিয়ে আলোচনা করব। ঠিক আছে, তো এই চ্যাপ্টারটা আইসিসি বোর্ডের ক্লাস 9 স্ট্যান্ডার্ডে আছে। তো যারা প্রথম ট্রিগোনোমেট্রি স্টার্ট করতে চলেছো, একটা নতুন পোর্শন একদম, তো তাদের জন্য এই ভিডিওটা সুপার হেল্পফুল অ্যান্ড সুপার ইউজফুল হতে চলেছে। আর যারা ক্লাস 9-এ ঠিকমতো করে উঠতে পারেনি বা করা হয়ে ওঠেনি, তাদের যারা ক্লাস 10-এ চলে এসেছো, তাদের জন্য ট্রিগোনোমেট্রিক আইডেন্টিটিস চ্যাপ্টার রয়েছে, তাদের জন্য ভিডিওটা সুপার হেল্পফুল অ্যান্ড এফেক্টিভ হতে চলেছে। ঠিক আছে, তো চলো স্টার্ট করা যাক টাইম ওয়েস্ট না করে। সর্বপ্রথম আমাদের জানতে হবে ট্রিগোনোমেট্রিটা কী জিনিস, হোয়াট ইজ ট্রিগোনোমেট্রি। ট্রিগোনোমেট্রি এই ওয়ার্ডটাকে যদি আমরা দেখি, অ্যানালাইজ করি, ট্রিগোনোমেট্রি এই শব্দটা এসেছে দুটো গ্রিক শব্দ থেকে। ঠিক আছে, হোয়াট আর দোজ গ্রিক ওয়ার্ডস? ফার্স্ট ওয়ার্ড ইজ ট্রাইগোনন, and second word is metron. Okay, তো ট্রাইগোনন আর মেট্রনের মানে কি দেখো। ট্রাইগোনন means simply a triangle. Trigonon simply means a triangle, and the word which is metron means measurement. That simply means a measurement. So measurement of what quantities of a triangle, measurement of what, কি মেজার করছি আমরা, ট্রায়াঙ্গেলের কি মেজার করব। হ্যাঁ, এখানে ব্যাপারটা হলো ট্রায়াঙ্গেলের কি মেজার করছি, ট্রায়াঙ্গেলের সাইডস আর অ্যাঙ্গেলের মাঝে যে রিলেশনশিপস। ঠিক আছে, সাইডস কটা আছে একটা ট্রায়াঙ্গেলের? 3টে সাইডস হয়। অ্যাঙ্গেল কটা থাকে একটা ট্রায়াঙ্গেলের? 3টে অ্যাঙ্গেল থাকে। তো সাইডসের সাথে অ্যাঙ্গেলের যে রিলেশনশিপস, ঠিক আছে, সেগুলোকে মেজারমেন্ট করা হয় বা সেগুলো ক্যালকুলেশন করা হয় in this branch of mathematics or trigonometry. So we can simply say that trigonometry is that branch of mathematics which deals with the measurement of the relationships between the sides and the angles of a triangle. Is it clear? তো এই হলো সাইডস আর অ্যাঙ্গেলের মধ্যে যে রিলেশনশিপস কোনো ট্রায়াঙ্গেলের, সেটাকে যে মেজারমেন্ট করে বা সেটাকে যে ক্যালকুলেশন করে ম্যাথমেটিক্সের যে ব্রাঞ্চে করা হয়, সেটাকে বলা হচ্ছে ট্রিগোনোমেট্রি। রাইট, এম আই ক্লিয়ার? তো এখানে দেখো, তোমাদের ক্লাস 9 বা ক্লাস 10-এর সিলেবাসে যে ট্রিগোনোমেট্রির পোর্শনটুকু আছে, সেখানে কিন্তু যে কোনো ট্রায়াঙ্গেলের সাইডস বা অ্যাঙ্গেলের রেশিও নিয়ে মেজারমেন্ট করা হবে না বা আলোচনা হবে না। The triangle to which we are restricted in class 9 and 10 is right angled triangle. Am I clear? Right angled triangle, not any kind of triangle, but in general trigonometry deals with the relationship between sides and angles of any kind of triangle. Am I clear? But in class 9 and 10 we are restricted to right angled triangle only. Okay, is it clear? Trigonometry is that branch of mathematics which deals with the measurement of the relationships in between the sides and the angles of a triangle. Sides and the angles of a triangle, right? কিন্তু এই ট্রায়াঙ্গেলটা for class 9 and 10 right angled triangle. for us, right? ক্লাস 9 and 10 এ আমাদের সিলেবাসে যে পোরশনটুকু আছে সেখানে শুধু রাইট অ্যাঙ্গেল ট্রায়াঙ্গেলের সাইডস আর অ্যাঙ্গেলের মাঝে যে রেশিওস গুলো আছে, ওকে, সেই রেশিও গুলো আমরা স্টাডি করব আর শিখব। অলরাইট, তারপরে দেখো এই রাইট অ্যাঙ্গেল ট্রায়াঙ্গেল এর রেশিওতে যাওয়ার আগে আমি তোমাদের একটা ইম্পর্টেন্ট থিওরেম বলবো। সেই থিওরেমটা হলো পাইথাগোরাস থিওরেম। ওকে, Pythagoras theorem. তো চলো হেডিং দিচ্ছি পাইথাগোরাস থিওরেম, দেখে নাও পাইথাগোরাস থিওরেম কি। তো কি এঁকেছি, রাইট অ্যাঙ্গেল ট্রায়াঙ্গেল, isn't it? Right angle triangle is a triangle whose one angle is 90 degrees. So this angle is 90 degree, right? আর রাইট অ্যাঙ্গেলের অপোজিট সাইডটাকে কি বলি আমরা, হাইপোটেনিউজ। The side opposite to the right angle of a triangle is called the hypotenuse. H দিয়ে আমরা ইন্ডিকেট করলাম এই সাইডটাকে। This is actually the hypotenuse, okay? And the other two angles are acute angles. Of course, if this angle is 90 degree, then the sum of the other two is definitely 90 degree. Then each of these two angles, okay, is definitely smaller than 90 degree or acute angles, right? So if this acute angle is theta, then this side, you know, is called the base. The side attached with the acute angle we are taking under consideration is called the base. There may be two sides attached with this acute angle, and out of these two sides one is definitely the hypotenuse, right? দুটো সাইডের মাঝে এই থিটা অ্যাঙ্গেলটা আছে, দুটো সাইডের মধ্যে একটা সাইড অবশ্যই হাইপোটেনিউজ হবে, ওকে? আর অন্য যে সাইডটা থাকবে হাইপোটেনিউজ ছাড়া অন্য সাইডটা, সেটাকে বলবো আমরা বেস, ঠিক আছে? দিস ইজ বিকামিং ইয়োর বেস, ওকে? আর এই থিটার অপোজিট যে সাইডটা, বা বলতে পারো হাইপোটেনিউজ আর বেস ছাড়া অন্য সাইডটা, সেটাকে বলবো পারপেন্ডিকুলার, পি, রাইট? So here H is actually the hypotenuse, B is actually called the base, and here P is perpendicular. Okay, all right. So in terms of these three sides, we shall define the ratios. But just before we come to the ratios, I want to tell you this theorem, Pythagoras theorem. What does it say? Pythagoras theorem says that hypotenuse square is equal to perpendicular square plus the base square. All right? Hypotenuse square is equal to perpendicular square plus base square. Actually, the theorem in literal form is something else. It says that the area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the other two sides. Isn't it clear? If you draw a square on the hypotenuse, right? If you draw a square on the hypotenuse, what should be the area of this square? The area of this square is hypotenuse square, isn't it? Area of this square. And if you happen to draw two other squares on the other two sides, okay, what are the areas getting? The area of this square is perpendicular square, area of this square is base square. Because you know the area of a square is simply side square, right? So you know, for a square all the four sides are equal to each other, right? So since one side is h, all the other three sides are also h. So its square is going to be side square, that is hypotenuse square. Similarly, if the area of this square is perpendicular square and the area of this square is base square. Pythagoras theorem says that the area of the square drawn on the hypotenuse is equal to the sum of the areas of the squares drawn on the other two sides. That is simply the one I had written before, right? Hypotenuse square is equal to perpendicular square plus base square, isn't it? Yes, that is, the mathematical form of Pythagoras theorem. The mathematical form of Pythagoras theorem. Keep this thing in mind, very, very important, right? Because this theorem is going to come to use in deriving some trigonometric identities, which I will show you afterwards, right? Is this clear? For example, I may tell you an application of this Pythagoras theorem. Okay, if a right angle triangle is there, okay, whose hypotenuse is 13, if it is in meter, say, and whose base is 12, then what should be its perpendicular? What should be its perpendicular? Perpendicular is something which is unknown, and that is what we need to find out. If this angle is taken to be the acute angle is theta, this is 90 degree, then this is becoming the base. I told you that other than the hypotenuse, the another side which is attached to this acute angle is supposed to be the base, right? And the one opposite to this acute angle is perpendicular. That is how we find it out. And the side opposite to the right angle is the hypotenuse, right? Hypotenuse is, is literally the longest side of a right angle triangle. Is it clear? Hypotenuse is becoming the longest side. So by making use of this Pythagoras theorem, we can easily find out the length of this perpendicular. So we can write hypotenuse square or 13 square equal to perpendicular square p square लिखलाम, base square is 12 square, right? So 169 is equal to p square plus 144, right? তাহলে কত হচ্ছে দেখো, 169 minus 144 equal to হচ্ছে আমাদের p square. Okay, অর্থাৎ this is becoming your 25 equal to p square. p equal to কত হচ্ছে root over 25, 5 meters, right? তাহলে এই triangle এর perpendicular এর length আমরা পেয়ে গেলাম perpendicular, right? In this way, okay, if out of the three sides of a right angle triangle, any two sides are given, the third side or the remaining one side can easily be determined by making use of this Pythagoras theorem. Is it clear? This theorem is very, very important. This theorem is exclusively applicable for a right angle triangle, keep it in mind. And the mathematical form of this theorem is hypotenuse square is equal to perpendicular square plus base square. Alright, the literal form, the actual statement of this Pythagoras theorem I've told you already, I'm repeating once again. The area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the other two sides. Am I clear? So that is what Pythagoras theorem says, and in the simplest form, the mathematical form of this theorem, which we need to remember for every time we go to do a sum of this chapter, trigonometrical identities, is hypotenuse square is equal to perpendicular square plus base square. Yes, that is the mathematical form of Pythagoras theorem. Very, very important. And from this theorem, from this expression, we may write perpendicular square is equal to hypotenuse square minus base square, and another thing, that is base square is equal to hypotenuse square minus perpendicular square, isn't it? By doing very little bit of side change, okay, or transposition, we get these relations. Is it clear? So now I'm moving on to let you know about the trigonometrical ratios of acute angle of a right angle triangle. Alright, because I've told you already that within the course of class 9 and 10 we are confined to a right angle triangle only. Actually, trigonometry deals with the relationship between sides and angles of any sort of triangle. Is it clear? Any sort of triangle, be it right angle, be it equilateral triangle, be it isosceles triangle, be it obtuse angle triangle, whatever be the kind of triangle. Trigonometry is very broad branch of mathematics. Once you get into class 11, you'll get to know how vast is trigonometry. Okay, so let us not talk about all those things, and let us not make you afraid. So let us continue doing the things which we are supposed to do within our present course of study. All right, come. I'm drawing a right angle triangle again here. Okay. If this angle is 90 degree, then this is the hypotenuse, right? If this is the acute angle that we take under consideration, which is theta, of course 0 degree less than theta less than 90 degree. All right, because theta is acute angle, so its value is definitely going to lie between 0 degree and 90 degree. That is what I have written. So this is becoming your base and this is becoming your perpendicular, right? Now the first ratio which was defined was sine theta. Sine theta, sine of theta. This is not sin theta, you know, this is sine theta, because its actual name is sine, S-I-N-E. Actual name is S-I-N-E, sine theta. Okay, that is its actual name. This has been shortened as sine theta. In this way, only the first 3 letters have been taken. This is not pronounced as sin theta, alright, because sin, you know, is pap. Sin mane to pap bhais, right? So this is not ever uttered as sin theta. This is sine theta. Okay, because its proper name or complete name is S-I-N-E. Sine theta is equal to perpendicular by hypotenuse of a right angle triangle. Sine theta is actually the ratio of the perpendicular to the hypotenuse of a right angle triangle whose acute angle is theta. Okay, after that is cosine. Cosine of theta. This has been shortened as cos theta. Cos theta is equal to base by hypotenuse. After that is tangent of theta. Tangent of theta. This has been shortened as tan theta is equal to perpendicular by base, right? Perpendicular by base. The reciprocals of these 3 ratios have been defined as cosecant or cosec theta, secant or sec theta, and third one is cotangent or cot theta. Alright, reciprocals of these 3 ratios: cosecant. Cosecant has been shortened as, you know, cosec theta is actually the reciprocal of sine theta, 1 by sine theta, equal to hypotenuse by perpendicular. Next is secant of theta is shortened as sec theta is equal to 1 upon cos theta, reciprocal of cos. Okay, so what is it getting? Hypotenuse by base, right? Next is cotangent. Cotangent of theta. This has been shortened as cot theta. Cot theta is the reciprocal of tan theta. That is base by perpendicular. Is it clear? So these 6 are the ratios, trigonometrical ratios. These are trigonometrical ratios. Trigonometrical ratios of acute angles. Trigonometrical ratios of acute angle. Am I clear? These 6 are the trigonometrical ratios of acute angles. So here in this side, what I have written is the complete names, which you don't need to remember. All you need to remember is the short names. Okay, only the short names. Only for the sake of your information, I have written here. All these things are given in your book as well. Now I'm erasing these things, okay, in order to save you from getting confused which thing to remember. These are things which you don't need to remember. If you're interested to know the full forms of these ratios, the full names of these ratios, then you feel free to know, okay, or remember. Otherwise you don't need to remember. All you need to remember are these names only. Sin theta is equal to perpendicular by hypotenuse, cos theta is equal to base by hypotenuse, tan theta is equal to perpendicular by base, and after that cosec theta is reciprocal of sin theta, that is hypotenuse by perpendicular, sec theta is equal to 1 by cos theta, that is hypotenuse by base, and cot theta is reciprocal of tan theta, that is base by perpendicular. Alright, so now tell me, if cosec theta becomes the reciprocal of sin theta, then sin theta is definitely also the reciprocal of cosec theta, isn't it? That is very easy to understand. Okay, so in place of sin theta, you may also write 1 by cosec theta. Alright, and in place of cos theta, you may write 1 by sec theta. In place of tan theta, you may write 1 by what, cot theta. Alright, so from these reciprocal relations, more 3 relations we are getting. Okay, am I able to write like this? Sin theta into cosec theta is equal to 1, isn't it? Of course I may. From this relation, in a very similar way, am I able to write cos theta into sec theta is equal to 1? Of course, isn't it? And from this one, am I able to write tan theta multiplied by cot theta is equal to 1? Of course I can, isn't it? Alright, now I want to tell you one important thing. Don't think that sin theta is equal to sin into theta. No, never. That is a blunder if you think like that. Sin theta is never equal to sin into theta, right? Now, sin theta is simply a ratio of the perpendicular to the hypotenuse of a triangle whose acute angle is theta. Okay, so that simply means that sin is meaningless without the existence of this angle or theta. For a triangle whose acute angle is theta, for that very triangle, the ratio of perpendicular to hypotenuse is sin of theta or sin theta simply, as we may say, as we keep saying, sin theta. Sin theta is never sin multiplied by theta, right? Theta and sin are not independent entities. Sin is defined with respect to an acute angle, and that very acute angle is theta. Cos is defined, or cosine or cos is defined with respect to an acute angle, which is theta. So sin, cos, tan, cosec, sec, cot, these ratios are meaningless without this theta. In place of theta, we may write other angles, other acute angles as well. Alpha, beta may also be the symbols which we may use in place of theta. that doesn't make a difference, but an angle has to be there. And within our course of syllabus of class 9 and 10, that angle will be an acute angle, because within the domain of our syllabus we are concerned with the right angle only, acute angles of a right angle triangle. Keep it in mind. Am I clear? That is all you need to remember. And this is something which is a blunder if you think that sine theta is equal to sine multiplied by theta. That is meaningless, right? Sine theta, so give little space in between the name of the ratio and the angle which you are writing, theta, alpha, beta, or any angle, 30 degree, 40 degree, whatever be the acute angle which you are writing. So there should be little space between the name of the ratio and the angle. Alright, that much I had to tell here. After this, okay, we'll come to the derivation of few basic trigonometric identities which you need to know. Alright. So what did I tell you while telling Pythagoras theorem? Pythagoras theorem has told you that hypotenuse square is equal to perpendicular square plus base square, right? That is what we got to know from Pythagoras theorem. And from this mathematical statement of Pythagoras theorem, okay, we got to get these two relations as well. Alright, now I will show you the trigonometric identities, the basic trigonometric identities which we need to know and keep in mind always in order to solve problems related to this chapter of trigonometric identities, or in order to prove some other trigonometric identities which will be given when the exercise of this chapter. Alright, what are those basic and fundamental trigonometric identities which you need to know? First one is sine square theta plus cos square theta is equal to 1. Okay, so let's come to proof. Sine square theta plus cos square theta is equal to 1. Okay, so how can that be proved? If I start with the LHS, right, LHS, you know, the left hand side, sine square theta plus cos square theta. What was sine theta? Sine theta was equal to perpendicular by hypotenuse, and cos theta was equal to base by hypotenuse. Okay, so let us write the very things over here. Perpendicular by hypotenuse whole square plus base by hypotenuse whole square. So what is that giving you? Perpendicular square by hypotenuse square here, base square by hypotenuse square, right? So if you take the LCM, that is becoming h square. Here is coming p square plus b square. Now see, p square plus b square is equal to h square as per Pythagoras theorem, isn't it? So in place of p square plus b square, am I able to substitute with h square? Of course, h square, okay, by h square. They are cancelled out and is giving you 1, right? It's equal to RHS. So this first trigonometric identity is proved. It's proved, okay. Now let's come to prove the second trigonometric identity. Second one is this one. Sec square theta minus tan square theta equal to 1. Okay, sec square theta minus tan square theta is equal to 1. Let us start in the very similar way with the LHS only. sec square theta minus tan square theta. What was sec theta? Have a look. Sec theta was equal to hypotenuse by base, isn't it? So I'm able to write h by b whole square. Of course, what was this? That is tan theta, p by b, right? Perpendicular by base, p by b whole square. What is that giving you? Hypotenuse square by base square minus perpendicular square by base square, right? So if you take the LCM as b square, in numerator you are getting hypotenuse square minus perpendicular square. Now see, h square minus p square, how much? It was equal to b square. Actually it is equal to, as per Pythagoras theorem. So we can write b square over here. B square by b square, they are cancelled out in order to give you 1. That is your right hand side. So this is proved as well. Okay. Now I will show you the third trigonometric identity. I'm erasing this portion. The third trigonometric identity is cosec square theta minus cot square theta is equal to 1. Okay. Let us start with the LHS. Cosec square theta minus cot square theta. What was your cosec theta? This has got erased a little bit. Cosec theta is equal to hypotenuse by perpendicular, right? Hypotenuse by perpendicular whole square minus cot square theta. Cot theta was equal to base by perpendicular. So b by p whole square, right? H square by p square minus b square by p square. If you take LCM, p square, numerator we are getting h square minus b square. Now see, h square minus b square is equal to p square, right? As per Pythagoras theorem, p square by p square cancelled out and we are getting 1 RHS, right? RHS. So this is proved as well. Okay, so these are the 3 basic trigonometrical identities which you need to remember. Okay, as the name of the chapter says, trigonometric identities. So these are, the very basic trigonometric identities which you need to remember. And if you remember these 3 trigonometric identities, you can get to prove other trigonometric identities as well with your help. Now I'll show you some other relations which you may get from these 3 basic trigonometric identities. I'm erasing the board, right? I'm erasing everything. Now I'll give you a synopsis of what we did in today's class. The very first thing we did, I'm drawing a triangle, right angled one. This is 90 degree, this is theta, this is hypotenuse, side opposite to the right angle is hypotenuse, and along with the hypotenuse, the other side attached with this acute angle theta is base, right? And the remaining side is perpendicular, or you may think the side opposite to this acute angle is also perpendicular, right? The trigonometrical ratios we got to learn today, got to know today, sine of theta equal to perpendicular by hypotenuse, cosine of theta or cos theta equal to base by hypotenuse, tangent of theta or tan theta equal to perpendicular by base, right? The other three or the reciprocals of these three are cosec theta is equal to hypotenuse by perpendicular, reciprocal of cos is sec theta is equal to hypotenuse by base, and the reciprocal of this tan theta is cot theta base by perpendicular. All right. So we can necessarily write that sin theta is equal to 1 by cosec theta, or cosec theta is equal to 1 by sin theta, right? Or sin theta multiplied by cosec theta is equal to 1, and cos theta is equal to 1 by sec theta, or cos theta into sec theta is equal to 1, or tan theta is equal to 1 by cot theta, or tan theta into cot theta is equal to 1, right? After that, I told you the trigonometric identities. First one was sin square theta plus cos square theta is equal to 1. Basic one, right? From here, by doing a little bit of side change, we can write sin square theta is equal to 1 minus cos square theta, right? Or you may write sin theta is equal to under root of 1 minus cos square theta, isn't it? These are the things which we are getting very easily. Or in the very similar way, you may also write like this: cos square theta is equal to 1 minus sin square theta, okay? Or cos theta is equal to root over 1 minus sin square theta, isn't it? Second one was your sec square theta minus tan square theta is equal to 1. From this basic identity, by doing side change, we can write sec square theta is equal to 1 plus tan square theta, or sec theta is equal to under root 1 plus tan square theta, okay? In a very similar way, we can write tan square theta equal to sec square theta minus 1, isn't it? Or tan theta is equal to root over of sec square theta minus 1, okay? Third one was your cosec square theta minus cot square theta is equal to 1. From this basic one, we may get such other relations by doing little bit of side change and simplification. Cosec square theta is equal to 1 plus cot square theta, okay? Then taking the square root of both sides, cosec theta is equal to under root of 1 plus cot square theta, isn't it? Again, cot square theta is equal to cosec square theta minus 1. Then cot theta is equal to root over cosec square theta minus 1. Is it clear? So these are actually the things we learned in today's video session, in today's class, and these are the things which you need to understand, which you need to remember, which you need to put over here. Alright, I hope you have got to understand these things, entire things, what I have tried to explain in this small session, and this is going to be a continuation. The next part of it is going to come very soon. I'm going to come with some typical harder trigonometric identities or problems and sums of other varieties related to this chapter. Alright, keep on studying. All the very best.